Hello students. So this is our topic application of Gauss law, that is electric field intensity due to a uniformly charged thin spherical cell. So let us consider a thin spherical cell. Spherical cell means which is hollow inside. Let the radius of this spherical cell is r. Now we have to find the electric field intensity due to this thin spherical cell at three different points. The point can be outside the cell, the point can be inside the cell, and the point can be on the surface of the cell. So let us consider the first case when the point is outside the cell. Suppose this is the point P, this is the point P, which is outside the thin spherical cell. Okay. Let the distance of this point P from the center of the cell is r. That is small r. Let this is the distance of the point P from the center. Okay. Now the first case is at a point outside the cell. The point is P. So taking the point P, to apply the Gauss theorem, we have to draw a Gaussian surface which includes this point P. Then draw a Gaussian surface. That the Gaussian surface is spherical in shape. This one. This is a Gaussian surface. You can draw a Gaussian surface like that. Now let the charge on the thin spherical cell is uniformly distributed, and the charge on this cell is positive charge. The charge on this spherical cell is positive, which is present on the surface of this cell. Okay. Now to apply this Gauss law, we have to consider a small area near the point P on the Gaussian surface. Let this is the small area of this Gaussian surface. That the area is ds. ds, and its area vector will point outside like that. This is the area vector. And the direction of electric field is also perpendicular to this area ds vector. This area ds vector. So to apply Gauss law, we know that according to Gauss theorem, the surface integral E dot ds is equal to q by epsilon naught time, where q is the total charge enclosed by the surface. This q is the total charge enclosed by the surface. Now, because E and this ds and this E, both are in the same direction, so this integral will become EDS is equal to Q by epsilon naught, and E comes out of this integral, we get ds is equal to Q by epsilon naught. Now what is ds? Integration of ds. Integration of ds is the area of this Gaussian surface. This Gaussian surface. Area of this Gaussian surface. Which includes this ds vector. Okay. So area of this Gaussian surface is 4 pi r square. 4 pi r square, because r is the radius, and that will be equal to q by epsilon naught. That will be equal to q by epsilon naught. From there E comes out to be E is equal to q by epsilon naught into 4 pi r square. Rearranging, we get the result like that: q by 4 pi epsilon naught r square. This is the value of E when we considering the point outside the thin spherical cell, the point P. This implies that the value of E is inversely proportional to r square, meaning that as r increases, the value of E falls as the square of r, as the square of r falls downward. Now the second point is at a point inside the cell. If the point P exists inside the spherical cell, then what will be the electric field intensity inside that? Okay, now this is the point P. This is the point P which is inside this spherical cell at a distance small r from the center. The center is the center O of the spherical cell. Now, taking r as radius, we have to draw a Gaussian surface. So, this is the Gaussian surface which includes this point P inside. Now, as you can see, the whole charge of this spherical cell is present on this surface. On the surface, inside there is no charge. So, Q, which is the charge enclosed by the Gaussian surface, is 0 here. Then from Gauss theorem, the Gauss theorem states that E dot ds will be equal to Q by epsilon naught. Now, as Q is 0, this Q is 0, as this Q is 0, so whatever be the value of ds, we get this one EDS is equal to 0. And from here, because ds is the small area on this Gaussian surface, this cannot be 0. The integration of this ds will be equal to 4 pi r square, that is E is equal to E into 4 pi r square is equal to 0, and this gives us E as 0. E as 0. So inside this spherical cell, the electric field comes out as 0. So there is no electric field inside the cell. Okay. So this one can be used as electrostatic shielding. electrostatic shield. Means that inside a hollow conductor there exists no electric field, and we are safe from the outer electric field if we are sitting in a closed hollow conductor. This is one of the important application of electric field due to a thin spherical cell at a point inside. Now if the point P is on the surface of the cell, when point P is on the surface of the cell, then the distance of the point P r is equal to the radius of the circle, radius of that spherical cell. Okay, then from E this relation E dot ds is equal to q by epsilon naught. ठीक है. Now the ds is what is ds here? 4 pi r square. This is the area of the cell now. Okay, so this value comes out E into 4 pi r square is equal to q by epsilon naught, and this gives us E is equal to q by 4 pi epsilon naught r square, q by 4 pi epsilon naught r square. Now summing up all the points, first one was outside, first one was outside. The outside the electric field is given as E, which was equal to q by 4 pi epsilon naught r square. Second one was inside, inside inside the electric field was 0. The third one was on the surface, on the surface, and on the surface we got E as q by 4 pi epsilon naught r square. Now coming to the point, if sigma be the surface charge density of the cell, surface charge density, you know the surface charge density. Surface charge density meaning charge per unit area. Surface charge density meaning charge per unit area. Q by A, Q by A, Q by A. So the Q becomes sigma into A. The Q becomes sigma into A, where this A is the area. This A is the area of the cell, and this comes out sigma into 4 pi r square, because 4 pi r square is the area of this cell. Then this relation will become this one q. Put the value of q here, that is sigma into 4 pi r square, and this is 4 pi epsilon naught r square, 4 pi r square, and we get, by cancelling the terms, we get sigma into r square divided by epsilon naught r square. Okay, meaning that E is inversely proportional to inside the electric field is 0. There is no thing to discuss here. on the surface. Now coming on the surface, q by 4 pi epsilon. Q is what? Sigma into 4 pi r square. Sigma into 4 pi r square. And this one is 4 pi epsilon naught r square. Cancelling some of the terms. It's 4 pi r square, 4 pi r square. We got sigma by epsilon naught. So E is equal to sigma by epsilon naught, which is the value of electric field intensity on the surface of the cell. Now the graph between E and R. E is electric field, and what is R? R, this is the point P distance from the center of this spherical cell. Now let us graph between E versus R. Take this axis as R, and this axis as E. This axis as E, and this is the origin. Now as R increases from this center of this cell, ठीक है, until R is equal to R, meaning till the point is inside the cell, the electric field is zero. So the graph is the R axis itself, this one. As the R becomes capital R, that is the distance of the point is equal to the radius, then the value of the electric field is sigma by epsilon naught, as we have seen. This is the value. Sigma by epsilon naught. And as R increases, as we have seen outside E is inversely proportional to R square outside. So E is inversely proportional to R square. This is the graph when R is greater than R. This is the graph, and this graph is the relation E is inversely proportional to R square. E is inversely proportional to R square. So this is the graphical representation of the electric field intensity due to a uniformly charged thin spherical cell. Outside it is E inversely proportional to R square. Inside E is 0, and on the surface the value of E is sigma by epsilon naught, which is the maximum value of electric field intensity due to a thin spherical cell which is at the surface of the cell. And outside the cell, the electric field decreases as R increases from this relation, and inside the electric field is 0 because there is no charge, and on the surface the electric field is constant, which is having the value sigma by epsilon naught, where sigma is the surface charge density of the cell. Okay, thank you all.